Hello and welcome to the fifth lecture in the exercise part of 22nd lecture, 22nd chapter in our comprehensive course on AI, ML and DS. Here we are doing this how to handle various exercise questions using generative AI tools. So these two parts are now left. Last we had done this feature selection. Okay. So now these two parts are left: model evaluation techniques and introduction to sklearn library. Its theoretical discussion we had already done. There were 11 lectures of 1 hour each in the theory part, but now its exercise questions are left. So what is left now is one question, which is this: using the make regression function from sklearn.datasets, generate a dataset with 200 samples, one feature, and noise level of 10. Fit a linear regression model and calculate mean squared error and R square matrix. Now, what we are trying to do first, let us try to understand. So, somewhere this kind of data we are trying to create, this kind of data, right? And if you don't add any noise and use the make regression data without noise, then it will put all the data points like these blue colored dots, and that will create a perfect linear distribution of data. But we want, and in practice also, practical data sets will always be having a trend, linear trend, but they will never be all on same line, right? So practical data points would be like those green points. So we are trying to generate that kind of data, and they have clearly helped us with use sklearn.datasets, right? Make regression function is to be used from dataset. 200 samples are to be created, just one feature. So just one feature means exactly this kind of diagram. Response variable will be 1 here, y, and feature x also will be only 1. So it's a very simple case. And then create a linear regression model. So model means this dotted line, which is passing as close as possible to various green colored data points, so that the sum of squared error is 0. Then calculate mean squared error R squared, and you can then also find root mean squared error if you want. Okay. So how to create the data set, that also they have given. So I think I don't need to do that, because this is perhaps the simplest possible case. Of course, I have to fit a linear regression model. So what I should think before directly jumping to my ChatGPT or other large language model. I should think first. So I will require from sklearn.linear models import linear regression. That will also be required. That is clear, where L is capital and R is capital, and there is no space between linear and regression. Now you see, so many things you had to remember earlier when this generative AI was not there at that time. And if you make just one small mistake, that from sklearn.linear model import linear space regression, or maybe you forgot that L should be capital and R should be capital, and all such small mistakes, that will create that silly delays in the code development. But now that issue will be resolved. And then these are from sklearn.matrix. You will have to import mean squared error, right? And then you will have to use it. At least that much is clear. Thereafter, there is not much. That first you will create a linear regression model. Steps are what? Import all necessary libraries. I have told you what are the libraries required. Then create X and Y. Then create X train and Y train using train test split. So that will also be needed to be imported. That from sklearn.model selection import train test split. Okay, so that will give me the train test split data set, that is a train test split functionality. Okay, so here this will be required, and then I will divide my X and Y into X train, Y train, X test, Y test. That will be next step. Then in next step I will create a linear regression object. Then in next step I will fit my linear regression object on X train and Y train. This diagram, which we have been using throughout the chapter, is very helpful diagram, right? So if I duplicate that cell and take this to the lower part, then it would be helpful. Okay, so we have done X train and Y train, and now linear regression was imported. Then LR was created, linear regression object was created. Then LR dot fit underscore transform X train and Y train. That will give me trained model, and then the trained model will be used for prediction on my test set X test, and that will give me predicted Y predicted. And then I will use Y predicted and Y test to compare my this accuracy, I mean to measure the accuracy of my model or goodness of fit of my model, right? This is how things will progress, that we know. But now if I try to do that, I have actually tried Then it took around 8 minutes or so, right? Now let us see how much time does it take if I simply ask it here. And also I may make a few modifications. This much is asked in the data set. So I will create a data set, fit linear model, calculate MSE, okay, and R squared. So I am adding one thing that calculate RMSE also, root mean squared error. Then maybe what else I can do is, okay, that much is enough, I think. Fine. Okay, if you want, plot the line of best fit, because if we don't have to do work, and if large language model is only going to do your work, then why not uh, put it to hard work? Okay, it is just like you are boss and it is employee, and you are making it to work. Okay, so you can see that within just a fraction of a second, what would have taken me around 8 minutes or 10 minutes, that is just completed in this much part, including the creation of data sets and everything, right? So I will now delete this whatever was given as the part of question, or okay, let us keep it, because it remains that this much was question, right? Okay, and here is the answer. So this I write as a markdown, and this is now next is my answer. So this is the code which it has given, and if you just put it, you can see how nicely it has converted everything. Mean squared error is 101, root mean squared error is 10 units, and R squared is 0.98. So it is a very good model, because R square 1 is 100% R square. R square is a measure of variance in the trained data which your model can explain, right? So it is 90 can explain 98% of the variance. That means that it is highly accurate as well as generalizable model. Accuracy is normally decided by these two things, and generalizability is decided by these things. And it gave even the plot also, which was similar to this plot. Some noise was added, so as a result it gave this kind of jitters. So very quick work and a big boost in the productivity. Then explain the concept of cross validation. Use five-fold cross validation on the data set which was created in previous question. So same data set I want to use, and evaluate the stability of linear regression model. Okay, so here I can put that question, because previous question was directly in the link, so I have put my new question in the this code only. One extra things will be, while training only you are using five-fold CV. Okay, so code will change some little bit. Five-fold cross validation, since the model is already trained. I already earlier also showed that normally the correct method is, while training we do this while we divide this X train, Y train, etc. At that time itself we put the five-fold cross validation. But if that is not the case, then at that moment what we do is, we have already created a trained model. So this fitted model is already there, but it was done without cross validation. But all the same, the fitted model is saved in my Jupyter notebook environment, right? So you can use that same model, trained model, and apply five-fold cross validation. There is no need to do all the steps from the beginning. So one library you will need to import, that is this sklearn.model selection, import cross validation score, and then create cross validation scores is equal to cross underscore valid underscore score model X, that is feature matrix, Y, that is response variable, how many folds, and what matrix you want to use for your scoring. So someone can use RMSE, someone can use R square, whatever metrics are provided by this function. And what metrics are provided, if you want to know, then I told you that you can look up the documentation by putting a question mark and execute. At that time, don't write this much, just write this much and put a question mark and press enter. So it will give you entire documentation that as a scoring what you are allowed to use. But previous had R square calculated, so this time also I want to calculate R square only, so that I can see that cross validation does some improvement in R square in this case or not, right? So these are the R square for each fold. First fold gave this much R square. Let me magnify this slightly. Okay. So first fold gave me this R square 0.986. Earlier it was just a 98, but now 986. Next time 977, then 987. Okay, then 982 and 984, and therefore the average is 9836 or nearly 984. Okay, so that means compared to these, 0.4% improvement has been seen. So if your thing which is you are predicting is of very large order, suppose you are predicting sales of a multinational company which is in billions of dollars, like company like Walmart, then just 0.3% improvement in your model will lead to huge saving in your for your company, right? Then standard deviation is 0.036. So earlier we have not calculated standard deviation, but if you calculate it, then that would be more. While here, if you calculate standard deviation, then this would be less. So that means your model has become now covers greater variance and with smaller standard deviation. So that is the meaning of what they are asking us to prove, that asking us to show that evaluate the stability of linear regression model. So you can say that as R square has increased and standard deviation has decreased, the stability of linear regression model has also improved. Okay. And this 12th question here, I'm deleting from this and converting these into markdown and putting my 12th question there. So demonstrate the train test split and cross validation to evaluate regression model on the synthetic data which was created in question 6. So question 6 was where? That was far on the upper side somewhere. This is question 5. Question 6, right? So now what I have to do is I will create, I have created some data in that and I am using that data rather than calling it for data in question 6. I will write it like this, that I have created synthetic data using following code, and then I will put in inverted commas entire code inverted commas over. Okay, and then I come back to my last question of the exercise. So last question says that demonstrate the use of train test split and cross validation to evaluate regression model on synthetic data on this synthetic data set. Okay, I am not writing that part created in question 6 because I have already shown how data was created. So demonstrate on this synthetic data set. Fine. And explain why it is important to use these techniques in the model evaluation. So you can use it this way. This is my question and you will see that it will create corresponding answer with code, everything very quickly. It gives some kind of introduction, what is cross validation, what are benefits of cross validation, 5-fold cross validation, and then no, this is here. Okay, so prepare the data, encode the categorical variable. So this is what it has done step by step, right? So let me paste this. I want to keep the answer honestly as it is given by my large language model. Just I will remove the unnecessary portion like certainly and then that introductory paragraph and all. Only the useful portion of the answer will be kept. So it says that in step 1 I have done this thing. Okay, then step 2 is train test split. Now all these things we are already knowing that what are the standard steps in the workflow. Step 3 is cross validation. I told you that before making model only, or that is while making model only, we should do cross validation. We should not create a trained model. Then thereafter, I think just why to use this. So that is the last part. And so this also is markdown cell and why to use and various things. While between these two, there will be some code. So this is the code, and this next also one cell which does the cross validation part. That is after step 3, right? So step 1, step 2, step 3, and thereafter the code for that. Now, if I quickly read step 1, prepare the data. So we will need to pre-process these features because categorical features are there. So we can encode the categorical features. So we are using one hot encoding. Then train test split. So split the data into X train, Y train, X test, Y test. Fine. Then perform cross validation and so on. So if you see here, then this is first 0th step, you can say, step, import libraries. Everything always starts with importing libraries. Fine. Then here it is using one new library, and perhaps we have not used this library. So ignore it at present. Don't worry. We are in any case going to discuss about this column transformer in much detail. Then second step is create the data frame. Here I can say that I can even print this data frame if I want, just for my extra cautiousness. And then I can put this much define features in a new cell, similarly train test to split in a new cell, and so on. But now I am trusting that it will create proper data only. So I am okay, let me put in the new cell because I want to show some things. Okay, so then this is the data set. Now define features and target. So again, if I come to that diagram, the standard green and yellow parts of the data, because that diagram shows entire data science life cycle. So now what I have done is this features and this train test split, that much I have taken to next 2 cells, right? Okay, fine. Now I am doing encoding. So I am using one hot encoder. Okay, so this is my one hot encoder. Then create a pipeline. No, first create a preprocessor. So let me delete this because I have shifted to the next cell. Then create a preprocessor. So take it to the next cell, add one or two more cells. Then now I have taken this preprocessor also, so I will delete that too. Okay, so delete it. Then create a pipeline. So take it to the next cell, create a pipeline. There is a reason why I am shifting the code to various different cells. Then fit the model. Then predict on the test data. That will be still in an next cell better. Then evaluate the model and print the result. We can talk about cross validation later on, but this is our standard data science life cycle. Since I have shifted all this to the next cells, now I need only this one. Now even this print statement is also not required. If I want to view my data, I will just write here. Now I will paste that well-known diagram once again. Okay, so I have pasted these two diagrams. One is this one and another is this one, because I personally, I am a kind of visual learner, and most of the people are, according to research. So when something is happening and simultaneously they show the teacher or the instructor shows some picture also, then we retain more. Okay, so this is importing library and creating the data set. So up to this page when we do, then we have created one full data set up to this, right? Let us see what kind of data we create. So we have created a data like this, in which there are these are categorical variables, and this seem to be some numeric variable. So that kind of data set is created. Okay, and now we want to go from this white colored data frame df into this stage, that is when feature matrix and the target are separated. So that is df dot drop y. So y is my target. It is some kind of classification problem, it appears, and 0, 0, 0 and 1 are showing some kind of categories, right? So say 0 is equal to diabetes negative and 1 is equal to diabetes positive, or 0 is equal to the tumor is benign and 1 is equal to the tumor is the carcinogenic, right? So that type of classification is there. So df dot drop y, when you say, that means keep all columns except that y column. So it will keep these columns, only y will be dropped, and that will become my x feature matrix. And in second time I keep only the y columns, so only this column, that will become my target variable. Okay, so then I am getting this kind of situation. X is my feature matrix and y is my target variable. Now from this stage I want to go to this stage, that is each will be divided into two parts, this green and yellow. So total 4 things will be generated. So x train, x test, y train, and y test will be generated. And at that time you will use train test split with test size is equal to maybe 0.2. So 80% in the train set and 20% in the test set, some constant for the random state. And first two arguments are important, that are your feature matrix and your response vector. Okay, so if you do that, now your x train, y train are generated. Now you are pre-processing for categorical feature, because so far you are not feeding your data to any algorithm. Okay, you have imported one algorithm here, linear regression algorithm, but so far you are not feeding. But when you want to feed your data to some algorithm, the algorithm will only understand numbers, it will not understand categorical values. So here my x train, x and y, that x particularly has categorical values like C, A, F. So I will have to use some kind of encoding. So I am using one hot encoder for categorical feature, right? So creating a categorical transformer. So categorical features I am writing, and then categorical transformer is equal to one hot encoder, drop is equal to first. When you write drop is equal to first, what happens, that also I have earlier showed. Suppose this kind of column is there, gender, and male, female, female, etc. is there, and I use one hot encoding, then this kind of two columns would be added, male yes, female yes. Okay, just beside these two more columns will be added, and here true or false will be added. Here I have written y and no, but actually y means true and no means false. So first column was male, first row was male, so therefore here it is written as the y for male, that is true, and female false. So true is internally stored as 1 and false is internally stored as 0. Then next column was female, so in male it will be stored as false, and in female it will be stored as true, and therefore 0 and 1. Similarly for all, but once these are created 1 0 0 1 0 1 1 0 like that, then these two columns are in number format, right? But then I don't need the old or the first means what was originally. This is that same gender column. So original that categorical column I don't need, so I will have to drop it. So that is what that line of code, that piece of code is doing. So I'm creating one hot encoder in which drop is equal to first argument is means explicitly specified. Okay, and then I create a preprocessor which has this column transformer, transformers, categorical encoder, categorical transformer, and categorical feature, and then remainder is equal to pass through. Remainder is equal to pass through will ensure that when features pass through this part of pipeline, at that time keep them as it is. Okay, so don't change their values 1 0 etc. Now create a pipeline, and model is equal to pipeline steps is equal to first pre-process your data and then apply regression, because I told you that regression model will never be able to do the training process if your features are still in categorical manner. So the advantage of doing it in this manner is that you are doing it in a reproducible way. So next time if some other new data comes, still I have to do only from this stage only. That is, this pipeline is created, then I just have to use that new X train and new Y train will be there. When I say new, you should understand that the features will remain same, the data types of each feature will also remain same, but these values will change. So these are how many values? 100 values, right? So instead of that, next 100 values come, next 100 values come, next 100 values come, because in organizations data can keep on changing. So I just have to create X train, Y train directly, and I will use the pipeline for evaluation. Okay, so model.fit X train and Y train, this step will be directly required now onwards. All these previous steps, all these steps will not be required once the pipeline is created. Then creating preprocessor, creating models, all those steps are not required. So when you do model.fit, what you are doing is this thing, that you are using your train set upper part and you are fitting your model, you are training your model. Okay, then what you are doing now, same train model you are taking here, and you are taking only this much part of the lower side, that is only the X test. You are not supplying Y test at that time to your trained model. So Y test is hidden, and you try to predict the corresponding values of the response variable for every row or every observation, every record in the X test data set. That will become Y predict, and its color is here pink, while original Y test is purple. Then you will compare these two, Y test and Y predict, to find the mean squared error. So first I am making prediction, model.predict, while prediction only X test is supplied, not never Y test, right? Because you want to hide the label, you want to check how your model performs on unknown data, and then mean squared error is equal to Y test and Y predict. So now you compare this purple and this pink. This is Y predicted and this is Y test actual. So that will give you what is the mean squared error between the two. And then you can also find R squared for those two, Y test and Y predict, and print those values, right? So this is what we are trying to do. Why I shifted things to new cell instead of that is I wanted to show you the output after each step. So I'm not showing X and Y now because they are very common. I'm not even showing X train Y test, but I'm just showing what it will show. As if I just write here categorical underscore transformer, okay, and press enter, you can see that it shows the that kind of object, categorical transformer, which is equal to one hot encoder, drop is equal to first. Okay, and if you want what is that transformer and everything, that question mark is always helpful. Question mark is there. You just go to that and it explains what is that one hot encoder and why it is what it does and everything, right? Okay, fine. Now similarly here processor is created, and that use column transformer, where transformer is equal to, I bring all of these on same line. I think it will not work. Okay, so fine. Otherwise, just for better visibility, let me try. If everything is on same line, then perhaps it will work better. Yeah. So transformer is equal to this cat, that is its name, okay, and what is to be supplied as next argument, then the categorical transformer which you created earlier, and what next argument, categorical features which also you created earlier. That out of your data frame, this is my data frame, X1 and X2, they were categorical feature. So that creates a transformer. Transformer, as the name itself indicates, it transforms the data set. Again, that is the preprocessor, and let me see what that preprocessor actually is. Okay, so I just write preprocessor, and you can see a nice diagram which shows what preprocessing is occurring. Now think, if you are sharing this kind of thing with your coworker or your client firm also often hire their own data analyst. That things communication becomes so easy. Okay, so you can share everything that I'm using column transformer with pass through, transformer with categorical one hot encoder. Okay, drop is equal to first, so original column I'm dropping, and these are my categorical columns, X1 and X2, and after transformation I am simply allowing a pass through, that is I'm not changing the columns in any way. Okay, So this is my processor object created, and it used the categorical transformer object which was created in the previous step, and the categorical feature list, that is what columns are names are categorical features, that was also created in the previous step. Okay, now this model is being created. So model is equal to pipeline, steps is equal to, here also let me bring everything on same line, because sometimes though the custom is what is given by your large language model, that type of format is the standard text 8 format, where the purpose is that used to the reader of the code, because Python puts a big emphasis on readability, right? So reader of the code should not need to scroll a lot, and therefore that things are going on different line. But for understanding, let us see model is equal to pipeline, where what are the steps. So first step is named preprocessor. You can name anything, but it is better to name it the same. You have created a preprocessor object. So, and second is component of your pipeline is regressor. Okay, and so here you are applying linear regression. So it clearly again shows that first data will be pre-processed by this pipeline, and then linear regression model will be applied. Right here also, if I take one line model, so let us see what that model will print. Okay, so it will show entire process, that what you are doing in the modeling. This is how one should remember the linear regression process. That first data is pre-processed using column transformer, and then one hot encoding is applied to convert x1 and x2, which are categorical columns, into numerical columns. Then a regressor object is created, and what was that column transformer, that is also shown here, and what is that categorical variables that are shown, how one hot encoder is applied with drop is equal to first option, and this is linear regression object. Now fit your model. You have created your model, but now you are supposed to fit it. Fit, when I say, that means still my model is not given X train and Y train. So when I supply X train and Y train, and when my model runs, iterates through X train and Y train repeatedly again and again and again, and learns patterns from it, that process is called fitting. Okay, so model dot fit X train and Y train. So that is this process, X train, Y train, this much, that are fed to the model, and that means my fitted model will be created. This is just a warning. It shows that column transformer, this will change in version 1.7. It is a future warning. So if you want to make your code future proof, then follow these instructions, and instead of that, that means instead of your code, make suitable changes. But I at present don't want to do that. So it has generated one pipeline. Okay, right? Okay, and now it is the, so now what you have done, you are here, you have a train model. Now you take that train model and you will supply the X test to it, and you will create prediction. So Y prediction is equal to model dot predict X test, and once that is Y predict, and once Y predict is generated, prediction set is generated, you will compare with the actual values of Y test, and Y pred and Y test will be compared with mean squared error and with R square, which two were imported in the very beginning using sklearn library. So from sklearn.matrix, import mean squared error and R square, R2 score. So that is the R squared. Okay, so R2 underscore score, and then let us print it. So test mean squared error is 0.30, and R squared is coming out to be minus 0.20. So it is very poor model that is coming out to be. That is okay, because this is such a random and synthetic and kind of nonsense kind of data. It does not come from any real source. So fine. Our purpose was just to show how to show the entire, fit the entire linear regression model using pipeline. So that we have shown. Now in the question it was asked one more thing, that if you see the question, then somewhere here it was asked in the question that plot the line of best fit. That is, I think it did not do. Also it did not do RMSE. Okay, so that means you can see that sometimes your large language model will also forget a few things, right? So that's you have to what you call pin it further, that you forgot to print RMSE. As such, RMSE is nothing. For example, here only print, I can just write f string test RMSE root mean squared error equals, here RMSE is equal to mean squared error to the power 0.5, square root of mean squared error. Okay, so I can write RMSE. I don't want to even format it to 2.2 decimals, 2 digits after the decimal, and then root mean squared error is 0.544. Okay, fine. Now cross validation score. So for which it has given this, that after cross validation what happens to the R square. So after cross validation, your R square, its negativity reduces substantially. So among the poorest of poor model, this is slightly less poor, you can say, okay, because that was minus 0.20. Now this is minus 0.08. So it is more positive. The bigger positivity and value of R square, the better the model is. And normally we get R square 0.9, positive 0.9, positive 0.85, positive 0.95, like that. So this is a totally useless and worthless model for practical purpose. But the data was also useless and worthless. It was, so this is an example of that adage of the data science, that garbage in, garbage out. Okay, so if you just feed any random data, then even after trying and finding the best model with five-fold cross validation, the R square still remain negative. It is almost zero now, but still some negativity remains. So how much variance your model explains? R square zero means what? How much variance your model explains? Then your model explains 0% of the variance, or in other words, your model is making just some random predictions. That's all. Its predictions are as good as just random predictions. Okay, so this is the end of this chapter. Now I just want to show one thing. Some people may find that, is it fair to use this kind of data, I mean this kind of method for doing uh, data science related questions, that is the code which you are generating. Now actually speaking, many people make that mistake, including myself. I had made that mistake, for which would have saved my, I think, 1 year, perhaps, or 1.5 years. That I thought earlier that coding is the heart of the data science. Now that is completely wrong. Instead, product-based approach and considering the entire data science life cycle and its various stages, that is the real important thing while learning the data science. Coding is important because coding ultimately makes your whatever you have imagined, that is possible, it makes it possible. That is okay. But now then next question arises is, okay, coding is important, but using AI tools for coding, is it a good practice? So I would say, or that old question, that my employer does not allow that coding by AI assistant, then what should I do? Now I will say that your employer in that case should be labeled as a regressive employer, and you should better leave that job as soon as possible, because in any case his firm would not exist uh, within maybe around next 5 years. So with AI tools, it is not a question of whether, but it is just a question of when and how. That means it is now not a question of whether you will use AI tool or not. If you want to remain in the business, you will have to use AI tool. So the only thing which is left is when you start employing your AI strategy as a business, and second, how you implement your AI strategy in your business. So you should try to convince your boss that, sir, the world has changed, and I would prefer to do it this way. Okay, and if he is still not convinced, then show him this particular diagram. If they are doing any worthwhile work in the data science space, then this is the diagram which shows the relative importance of various things in the data science life cycle. Okay, so this is my data science life cycle using which I am teaching. Okay, and this is what is the actual diagram given by Google's expert in machine learning, and he says this is how I have taken it from one important blog, that another great illustration of impact of software engineering compared to actual machine learning code and knowledge is this visualization by Google, showing how much the explicit machine learning related code is compared to everything else in the machine learning project. And this black colored small dark black dot, that is the machine learning related code. But before that you have to do so many things. First you have to lay down entire infrastructure. Now infrastructure means there is a concept of infrastructure as a code. Okay, so lay down infrastructure does not necessarily mean put heavy machinery, but you have to create pipelines for ETL, extract, transform, load. Okay, so extract means take the data from somewhere, maybe from a website, maybe from some SQL database or NoSQL database, or maybe from API. So take data, extract it, then transform it. Transform may include that feature scaling, then various pre-processing techniques like encoding and everything. So collection, data collection, feature extraction, feature engineering, making new interaction feature and all that. Verification of your data, whether some anomalies are left or there. For example, age is negative or salary is negative. So that type of record you have to first correct. Okay, because no person, or age is 500 years. Now that is not possible. So such things you have to correct, right? That is called invalid data, or there is some anomaly in the data. So you have to correct that. Okay, now that part is this thing, that is problem identification, business understanding, ETL, EDA, because when you do exploratory analysis and visualization, then only you will find the anomaly. So data collection, feature extraction, data verification. Then you will do feature engineering also, and throughout the process you will have to do machine resource management. So how much computing power will be required? That is each algorithm has something called O complexity, order of n square. So if you are dealing with a large amount of data, as large as Google is dealing with, so at that time, if one algorithm is order of n and another algorithm is order of n square, so that means to perform the same task, if first algorithm is taking 5 minutes, then the second algorithm will take 5 square minutes roughly. So that is 25 minutes. Okay. So first thing, resource not only means RAM and hard disk, but resource also means computing time, okay, or complexity, time complexity, space complexity. So all those things you have to manage. Then analysis tools you have to learn. So analysis tools can be, you can even do basic analysis using Excel. Then some visualization, quick visualization you can do using Power BI, Tableau, whatever you are comfortable with. This course was based on Python, and I wanted to keep it that way, that it does not use anything but pure Python. That is why. But a data scientist can use any tool. There is no restriction. So if he is comfortable with visual tools, he should use those kind of tools and make the whole process faster. The purpose is only to make this whole data science life cycle more efficient. Then process management tools you have to use. Then finally your model is created. For example, here I created one model. Forget that its R square was very poor, but suppose its R square is 0.95. We earlier did create one such model, just as a for my reputation's sake, I have to show that. Yeah, so this was my earlier model. It has very decent R square after cross validation 0.983, right, and very little standard deviation. So I can say that I have created model. But now what? So I have to do then serving. I have to serve my model. Serve my model is called, here in this life cycle, it is called model deployment. Here serving means I have to provide either a server on my own premises, or I have to use some cloud server like Google GCP or Amazon AWS or Microsoft Azure. Okay, and there I will have to shift my entire model, trained model, and I have to create some mechanism by which the new data is directly entered by user on that so I have to create one user interface, and then the model will predict, and the predictions will be visible to the user, and everything else must be hidden from the user, right? So everything else must be hidden means he should not see the model, he should not see the data, he should just get the user interface. For example, diabetes prediction or whatever data set is, then he will just need to enter here this data set about which 98. So what was the data? The data was at that time this make regression data set. Okay, fine. So if I write one more here and say df, then this kind of data. So user interface would provide something for him to enter as x1, x2. So 5 input fields will be there, x3, x4, and y will be output field, which will predict the class 0 or 1. Okay. Now that model was pretty accurate, so I can deploy it on some cloud, and the user will enter x1, x2, and other features were x1, x2, then x3, x4. Yes, 4 features were there, and he should be presented with y. Nothing else should be visible to the end user. Okay, because end user will be a layman. He will not be a technical person, or not necessarily a technical person. So that is called model serving. Now what happens during the model serving is continuously your technical team should go on monitoring the model, because there comes something called data drift. So sometimes data drift occurs, or sometimes model drift occurs, and you have to monitor the model, and what is this model drift and all that we will see. But in that case you have to again go from this stage to, you can see, monitoring takes you back to data acquisition. So you have to acquire that new data and repeat this process, and EDA and feature engineering and new model will be created, and that improved model which you are creating, that should replace the old model which you have deployed on your server. Okay, and this process should occur uninterrupted. That means while your users are using the old model, simultaneously you should start preparing your new model, and when your new model is ready, better model is ready, which can handle this model drift and data drift, then within just a fraction of a second or within few seconds, it should be able to replace the old model. Okay, so that is called model monitoring. So real skills which you have to gather is this thing. That is why I put so much emphasis on the hypothesis testing, so much emphasis on data collection, data cleaning, feature extraction part. Okay, and similarly, whenever we will do at the end, I will show you this deployment also. We will actually deploy our models on various cloud platforms. Okay, so, and I will show you one or two examples on monitoring also. So the real thing about the real benchmark of a good data science course is not whether it teaches coding or not. Yes, coding is required, and that is why we kept around 16, 17 chapters on Python, and then also 2 3 more chapters on statistics with Python, right? And in every chapter also I am still explaining every line of code, but that much is the role of coding. Okay, the real role is this kind of holistic picture should be in your mind. And this part is also important. The client comes with his business problem, you should have business understanding and you convert it into a data science problem. Then you start this whole process, you develop your model, deploy it, and create dashboard, and your client will just be interested in final dashboard, so he will just use this dashboard on your server. That's it. Okay, so this is now a giant company like Google is telling this, and you refer to any experienced data scientist who has worked in industry, he will tell that initially, yes, coding would be needed, but later on, the knowledge of how to deploy your model, how to monitor your model, and all those things also, that becomes more important. How to extract the data, how to validate the data, verify your data, those things are more important. Okay, so give importance to coding, but don't give so much importance which is more than what it deserves. And that is why these AI, these coding tools, they are a boon, so that they allow you to focus on this holistic picture always, and they allow you to focus on the solving business problem, and you can afford to give less focus to machine learning code. So from next chapter onwards, we will be freely using this AI tools, right? So now from next chapter onwards, our course will undergo a metamorphosis, and it will become an AI based data science course. So you will really enjoy, because the hard work of these 22 chapters will now pay off. Okay, some new concepts will require some hard work, but very few concepts are left now. Very few means hardly I can count them on my fingers. Okay, so see you in the next chapter. Here chapter 22 ends.